Hi. Yeah, this is AJ, founder of Radius. We today talk about the coordination layer for sustainable rollups revenue. Actually, Radius is building various types of sequencing, such as decentralized sequencing, shared sequencing, and based sequencing to help rollups generate much more profit than as it is. So we all know that there will be millions of rollups because compared to smart contracts, there are some distinct benefits that these projects actually can get if they choose to build their own rollups, such as flexibility, scalability is the obvious. And then also there are, right now there are quite mature development environments, such as rollup as a service providers or rollup framework as well. So such as rollup frameworks, OpenStack, zkStack, and Madara, Polygon CDK, those kind of mature. So you can build your own rollups using this one of the frameworks. And then also Rust providers actually help deploying these rollups on behalf of you. But when you think of the building your own rollups, there's one thing that you should consider compared to smart contracts. When you use smart contracts, the only thing you need to do is just to write a smart contract in Solidity or whatever language, and then the base layer is going to take care of the rest. But with rollups, you need to run a sequencer node for yourselves, which means that you need to keep the latest state of your own rollups by yourselves. But the problem is that running sequencer nodes is there should be a huge amount of operational cost, which means that there should be some concrete revenue source that you can cover this cost. So right now, if you are using the Rust provider, there should be our centralized sequences. But question is, are we okay with these centralized sequences? Some people actually say that we are okay with the centralized sequencers, even though these sequencers actually stop working for more than 50 hours. There's no impact. I'm quite surprised to hear that thought, but some rollups actually stopped for many hours, which means that this is a really bad user experience. So, and then also some centralized sequencers insist that they are not doing any malicious behavior, such as front-running or sandwich attack, but we are not. There's no guarantee that they actually not doing it. We just only trust them. So sandwich attack is kind of not detectable. And then the reason why we are sort of okay with centralized sequencers because we choose to be okay for now. Because for rollups, these execution stacks such as fraud proof or validity proof is more important than sequencers. So that's why we just keep these centralized sequencers running for these rollups. But right now, we need to decentralize. So actually, decentralization on rollups is different from decentralized on layer 1. Because you can think of why we came up with this rollup approach because of the scalability. We need rollups for scalability, so there should be nothing to compromise this scalability while building these rollups. So that's one thing that you should keep in mind. So Radius is building kind of solution to this decentralized sequencing without compromising this scalability. I will explain details later. So as I explained earlier, we need some kind of revenue model to cover this operational cost from this running sequencer nodes. So right now, the most revenue source is from the end user side, especially like transaction fees. And the cost on sequencer side is just to post this the result of like a fraud proof or a validity proof on Ethereum for finality. That's the only cost. So, to to make these rollups sustain in economical way, there is two ways to do that. First, we enhance the existing revenue model. Second, we find additional revenue source for rollups. First, if we want to enhance this existing revenue source, we need prevent user attrition from happening. So which means that we need keep users active and then prevent this user attrition as well. But point is that these rollups always be some kind of criticized with the fragmentation. So there are not many like use cases because we cannot make these rollups interoperable with seamless way. So that's those part that Radius is right now solving. So I want to explain that what kind of why this coordination is needed for rollups to generate much profit. Before explaining details, I'd like to go this transaction flow. When you create transactions on rollups, your transactions will go to there are many entities when these users transactions on rollups end up confirming on Ethereum for finality. One, these transactions go to layer 2 sequencer, and then build that is a relay. Sorry about that. A relay and layer proposer, those kind of entities. So we need some kind of coordination between these multiple entities to make revenue for rollups. So first, coordination is needed between users and sequencers. This is for to prevent this user attrition from happening. So basically, there are three properties in decentralization. One, censorship resistance, liveness. The last one, safety. So this one is for censorship resistance. So right now, centralized sequencers actually can censor your transactions. So we need to come up with some kind of solution to prevent this censorship from happening. So that's why we using encrypted mempool and order validation, which means that your transactions is encrypted and then submit to sequencer, and the sequencer is gonna confirm the order of these transactions while these transactions remain encrypted. So there's nothing that this sequencer can do, such as manipulating order to extract bad MEV or censorship, those kind of things. This sequencer cannot do. So that's how we can provide this censorship resistance with using this encrypted mempool. And then users will get some kind of pre-confirmation or order commitment saying that your transactions will be included in a specific index of next block. And then after this sequencer post this next block, user can find out easily this promise is kept or broken. If it's broken, user can claim this sequencer can be slashed. So that's how we enforce this censorship resistance with encrypted mempool. So this is the way to protect users from these malicious sequences. For liveness, there should be some coordination between multiple sequences. So right now, centralized sequencers only one leader to build a block, but to decentralize the sequences, we have multiple sequencers in a sequencer set. So a leader, one sequencer is selected randomly as a leader. This leader is going to build block and then also issue the pre-confirmation for rollups. Other sequencers do such as followers to keep sync up this the latest block with our leaders. So if this leader stops working, one of the followers is going to take this leader's role to keep this whole system working. And then actually encrypted mempool is really doing a good job with this model because this leader-based sequencing model is the kind of, we need some kind of trust assumption to make this whole leader-based sequencing working. But using encrypted mempool, even though there's only one leader, there's nothing that this single leader can do, such as manipulating order or something. So we can just trust the minimized way decentralized sequencing. And then for safety, we actually doing this based sequencing stuff. I don't know how much you guys are familiar with this based sequencing. Based sequencing concept is actually like a layer 1 proposer is going to do this layer 2 sequencers role. So layer 1 proposer is going to building blocks for all layer 2 stuff, which means that if layer 1 proposer build blocks for rollups, it can guarantee that these actually transactions on rollups can be ended up on layer 1 as soon as possible. So that's one. This based approach actually leads to better user experience because for this safety stuff. So right now, decentralized sequencers like censorship resistance and liveness is really actually help rollups to enhance the existing revenue model, which is to protect users and then to keep users inside their rollup network. We need to also come up with a better idea to provide additional revenue model for rollups because, as I said before, running sequencers actually cost a lot. So that's why we also considering this additional revenue so we can make sure that these all rollups sustain in economical way. So that's why we came up with a shared sequencing solution. The concept is that this is the coordination between sequencers and shared sequencers. So the simple explanation is that this one shared sequencer is going to build blocks for multiple rollups. So it can make sure that synchronous composability can happen because this one single sequencer is take the role of building rollups for multiple rollups. So in that case, we can with this shared sequencing, there are many user scenarios such as cross rollup MEV, cross rollup arbitrage, or a bunch of new transactions type can happen, such as if you want to buy if you want to swap some tokens and swap the tokens on rollup A and then buy the NFT on rollup B, you can also use asynchronous solution, but with this synchronous composability, I think these transitions actually can be done much more faster than asynchronous composability. So if this value that your transactions is aimed to handle changes a long time, this synchronous composability is the one that you should go for, use. So this is the end goal of Radius architecture. Actually, right now, we want to help these rollups to generate much more profits. So right now we are building this, we call it block space network. Is that connecting buyers who wants to buy block space from rollups and sellers, which is the rollups. So any builders, any sophisticated one can actually build blocks for rollups and then give them much more profits. And then these sequencers on rollups doesn't have to be sophisticated to extract value or make profits from building block space. So right now we are actually deploying our decentralized sequencing on AVS, Eigenlayer Testnet. So if you want to use our decentralized sequencing solution, you can have your own AVS and then you can have your own sequencer sets, which means that we are not take control out of your rollups sequencing thing, but you can keep your sequencing sets inside your control. So, and then if that diagram, if this rollup B and rollup C wants to be interoperable, we can provide this shared sequencing model so one builders can buy block space from rollup B and rollup C, and then there should be some kind of cross rollup transactions which is more valuable and then bring much more profits for these rollups as well. So that's why we are right now focusing on this decentralized sequencing and shared sequencing as well. So it's kind of, you can think of like a PBS style for rollups. So right now, proposer actually delegate the right of building blocks to builders, which is more sophisticated in terms of the building blocks to generate profit. We also can do the similar thing. So builders can actually build blocks for rollups sequences. But the important thing is, if you keep your sequencer centralized, you cannot apply PBS, because if centralize the sequencer and PBS, which means that you are going to extract value from your end users. So that's why we need to decentralize. That's why we need to decentralize the sequences and then apply this PBS style to generate profits. So that's Radius' plan to help rollups keep the economical sustainability. Okay, that's end of my talk. Thank you.